right on the regression line. The point's actually here, so the point's above it. That is the unexplained. So that is the unexplained. For one, add that up for everybody. Add that up for everybody. Divide, you don't need this, right? That's where it comes from. Divide by the degrees of freedom, and then take its square root, and that's where you get your standard error. How does it change? Two ways. One, better R squared, closer fit, it gets smaller. This is what you do need to know. You don't need to just know that it comes from the residuals. But better R squared, closer fit, it gets smaller. But the second way it gets smaller is larger sample size. For the same R squared, larger sample size, the standard error gets smaller. Because the sample size or degrees of freedom come into play. Those are the two ways to make it smaller.
I was just curious, does residuals refer to the points, the data points?
The residual error, the residual error is sort of, is the predictive line predicts that this point should be here, but the point's actually there. And so the part that's unexplained by the model is sort of this predictive line. That's the unexplained. So if you have like that one problem set a couple weeks ago when all the data fits it perfectly almost, and you have a y bar there, then almost everything is explained. There's only tiny bits that are unexplained. And as a theoretical, if the lines are actually on a straight, if the points are on a straight line going vertically out, that's when you get 100% for a simple XY model. Then it's 100% explained. There's no residual error. Does that explain? But so yeah, it's the part that's not explained by the regression line.
Okay.
The line predicts it somewhere, but the point's actually